The Geography and Earth Sciences junior faculty hosts a speaker series to highlight all stages of research with work spanning the many disciplines, degrees, and interests that comprise the department, including but not limited to urban and regional planning, ecology, meteorology, and climate modeling, hydraulic sciences, food and human geographies, and socio-ecological system science. And today we're very excited to be joined today by Dr. Qiusheng Wu. I just want to read a little bit about Dr. Qiusheng's bio as an introduction for Dr. Wu. Dr. Wu is an assistant professor in the Department of Geography and Sustainability at the University of Tennessee, Knoxville. He is also an Amazon visiting academic working in the AWS Deep Learning Organization. And Dr. Wu's research interests include geographic information science, remote sensing, and open source software development. He has developed several open source packages that have been widely used by the geospatial community, such as GMAP, LeafMap, Geospatial, LiDAR, and white box tools front ends. His research has been funded by the US Department of Defense, NASA, and USDA as well. You can even check out more on Dr. Wu's work by looking at his personal website and YouTube channel as well for more information on Dr. Wu's work and his research as well. And we're very thankful and excited to hear from Dr. Wu's work. So welcome, Dr. Wu, and I will turn it over to you for your presentation as well. And thank you also for sharing in the chat your slides as well for others to refer to.
Yeah, thank you very much, Dr. Zunika, for the invitation and also the introduction. I'm honored here to share some of the work that I have been doing during the past 2 to 3 years. And so the title is Geospatial, Cloud Computing, and Data Visualization with Open Source Software. So I send the link to the slides in the chat. You can also scan the QR code in the lower right corner. And here is the outline of my presentation. I will first introduce the interactive web app for creating satellite time-lapse animations just within a couple of seconds with less than 1 minute. So you can create time-lapse animations for any locations around the globe. You can try out the link upper right corner over there. So you can try out all kind of satellites. It's all free. You don't have to pay anything. And the source code is also open source. You want to look at the source code, you're welcome to check out the link. Then I will introduce Google Ascending Cloud Computing and also GMAP, basically the under the hood, how this interactive web app was created. And then later I will introduce some of the additional open source projects that I've been working on and some additional resources. At the end, I will be happy to answer any questions that you might have. So for the web app, this is what the interface looks like. You're welcome to try out the link upper right corner there. And earlier this month, I also published a kind of the article on the conversation, basically just introduce the audience how they can use free satellite data and also free cloud computing resources to look at the environmental changes and how the Earth is evolving. And this is one application that has been widely used on social media. So it's actually very simple. You go to the app, you select the area you like, and then you can export the ROI or you can upload the ROI from your computer. Then you just select what satellite do you want, what band combination do you want, the speed, the year, and other parameters. Then you just click a submit button. You will be able to create a time-lapse animation for any location you like for most of the satellite data in the public domain. So now you don't really need to have a powerful computer. You don't need to have the commercial remote sensing software to create animation like this. And it only takes less than 60 seconds. You can do that for anywhere. And this is very, very useful because you probably have seen some time-lapse animation on the internet, but most of those are limited to just RGB, right? But if you're doing remote sensing, sometimes you want to highlight specific features using different band combination, different resolution, and you can also add all kind of animation or text to that. So makes it very, very easy to use. And so next, I'm going to show you some examples that are quite striking. For example, the drawing the ROC. So these are all based on Landsat data since the 1980s. So we have almost 5 decades of satellite data available. Now you can basically look at the changes of the Earth very, very easily. On the right is the mining in Canada, the coastal expansion in Dubai, meandering rivers in South America. So those might be interesting for those studying fluvial geomorphology, and deforestation in Brazil, landslides in Peru, and urban expansion in Las Vegas, or in China, and in Mexico. And this one is in Charlotte, North Carolina. So you can see, for example, the expansion of the international airport over there in the early, I think almost 2010 or 2008. You probably know better than me, but at least you can see, for example, how the city is growing, like using satellite. This is not like super high resolution, but at least you can see overall how the landscape is changing. And so this one is coastal erosion. You can also clearly see how the coastline has been retreating during the past couple of decades. You'll be interested to see what kind of driving factors. So all the things in here are just trying to make it easier and more accessible, but there are lots of scientific questions or resource questions you can stem from this phenomenon. And for example, the formation of the river delta, river dynamics, and besides using the Landsat data, there are a lot of other satellite data available out there. This one is using MODIS data. So you can just every time 1 hour you have one time snapshot. So you can create this kind of animation just to showcase how, for example, the temperature is changing around the globe, and ocean temperature, even vegetation dynamics. This one is using long-term MODIS data and DVI. So you can see basically how the vegetation is changing at a continual scale, and it's just like human breathing. You can see it's quite dramatic, and this is something we'll not be able to see if you're just looking at one-time snapshots. So this is more like long-term and very useful. Besides long-term scale, like global scale, but there's like low temporal frequency. There are also a lot of data. There's high temporal frequency for weather and climate events. In this case, is the GOES satellites by NOAA. So you can see it can capture the volcanic eruption. Within a couple hours, you can also capture a wildfire. And this is very, very useful. And keep in mind, I'm just showing you the images, but you can do a lot of computation behind. You can do a lot of analysis. So on the right, show you, for example, the wildfire, but you can also detect the boundary of the wildfire in near real time. So this will be useful to inform the residents over there, like what is happening and how is it evolving, whether you need to evacuate or not. So these are all critical information that we can use to prepare for or respond to natural disasters. And besides like the creating time-lapse animation, I also developed some of the packages, for example, allow you to do interactive mapping, visualizing vector data, raster data, creating some simple maps. And these are all free and open source, so you don't need to pay anything to do that. And the point is that this is all on the web, so it is not like running on your local computer. So your users will be able to access this using a cell phone, the iPad, the tablet, and you can visualize tons of data in the cloud using these free cloud computing resources. So this is what's available in the app. You're welcome to try it out. And next, I want to quickly introduce Google Earth Engine. So the app that I introduced earlier, under the hood, was using the Google Earth Engine cloud computing. And so for those of you who are not familiar, I will just quickly introduce it. So it's different from Google Earth. Google Earth basically is just a digital globe, allows you to visualize satellite imagery, but it doesn't provide any analytical functionality. So you can see, but you cannot pretty much do anything. Earth Engine, on the other hand, is like compute backend behind Google Earth. So you can visualize imagery, you can do computation, you can export the results. And there are a lot more things you can do, and it's a lot more powerful. But it's free for research and education, and you can sign up for an account, and then you can start using that. So here is a kind of analogy why like we want to use Google Engine cloud computing. So think about in the past, if you need to watch a movie, right? You buy the DVD, takes some days to arrive, or you can buy from a local store, and then you need a DVD-ROM to load the DVD, and then you need a decent computer in order to be able to watch a movie. But now everyone just use a browser, using an app, then you can watch movies from any streaming services, for example, Netflix, Amazon Prime, Disney Plus, right? So it's much easier. It's the same idea about the cloud computing in the geospatial domain, right? Essentially, we just want to stream the geospatial data. We want to do the computation in the cloud. We don't have to actually download anything to our local computer. So this kind of, especially the past few years, it's getting a lot more popular. So we're kind of in the transition stage. Like everything right now is moving in the cloud, and even NASA, USGS, all the data pretty much right now in the cloud. So we need the functionality to be able to visualize data in the cloud and then do the computation in the cloud. And one of the things that classic applications of Google's engine is basically, for example, creating cloud-free images. So you can imagine remote sensing, we acquire tons of remote sensing data daily, right? And you're always going to have some cloud if you're using optical sensors. And using Google's engine cloud computing, you can create this kind of cloud-free imaging just within seconds. And it doesn't matter the scale, you can do it at a global scale. So it just can do a simple medium filter, basically taking a bunch of bad quality pixels and then just pick the best one and then do it at the global scale. And then you will end up with some images like this. You might have seen some of those imagery on Google Earth, right? So when you see Google Earth, most of the imagery looks perfect. Most likely, some of those imagery have been processed using Google Earth engine, because there's no way you can get a cloud-free imagery at a global scale using optimized optical sensor, because the Earth is covered by cloud at any time during the day. 60–70% will be cloud. So this is very useful if you're doing large scale using optical sensors. One of the big advantages of Google's engine is that it has a huge data catalog. So right now it's actually over 80 petabytes, so 80,000 terabyte of data, and over 1,000 data sets. So it actually keeps growing. And most of the data in the public domain are already there. Landsat, Sentinel, MODIS, a lot of land cover, weather, climate data, you name it. So if you need any data, you can just go there and then do a quick search, and then you'll be able to find out, see if the data is available. If it's not, you can upload data to your account, so you can have like free 250 gigabyte data for you to access. And so Google's engine provides the API called the JavaScript API, Python API, and another one called REST API. Here's kind of a quick comparison between the two APIs. So the JavaScript API, it has a lot of documentation, easy to get started, and it has a lot of interactive functionality. But the downside is that compared with Python, Python has limited documentation, but most right now in the data science community, people learn the Python first. Not many one like know the JavaScript, and you are kind of limited for the JavaScript API. You are limited to the interface. There's not really much communication between your computer. So if you have some small data set, you want to do the conversion on the fly, it's not possible. Python is a lot more flexible, and you also have a lot of IDE, basically the editor that you can use to write code and then debug code. So it's a lot more flexible, and you can also integrate with desktop JS, for example, QGIS, ArcGIS, and you can also do deep learning. So Python has a lot of functionality that is not possible through the JavaScript. And again, the downside is that Google's engine itself, the official package, doesn't provide visualization functionality. So it cannot even visualize an imagery dynamically. So you have to utilize other mapping libraries actually to that. So it was a lot of work. So I kind of built on top of that is trying to develop this interactive functionality that allow users to visualize the data very easily and do the computation. You can also export the data. So do you see here, this is the interface of the JavaScript API. You think about the API has two components, visualization and also computation. The JavaScript API has both. The Python API pretty much only has computation. It doesn't have the visualization capability. So I built on top of some of the open source libraries, and then develop a lot of interactive user interface, and now so it's much easier. So you can have kind of similar user experiences, just like you're using the JavaScript, and it has a lot more flexibility in that. So this is about like GMap, and so next I'm gonna just show you introduce a GMap and just show you some features so they can have some visual impression like what kind of things the GMap can do. And it's open source. It's hosted on GitHub, so you're welcome to check out the source code. It runs on all the major Python Jupyter environment, for example, Jupyter Lab, Jupyter Notebook, Google Colab, Amazon SageMaker, or even like Microsoft Printed Computer. And you can also develop interactive web app, not just like writing Python code as flexible. And here's the documentation website, gmap.org. You're welcome to check out the website. A lot of documentation, tutorials, and API documentation. You were going to try it out. And I also published a short paper describing the package in 3 years ago, 2020. And so luckily, I was able to get some funding from NASA last year to support the development and maintenance of the GMap Python package. I also developed a lot of tutorials. So during the past 2 to 3 years, I spent a lot of time not only develop features that users can use, but I also try to teach people how to use those features so that to make it easier for you to analyze data in the cloud. So you can check out my YouTube channel. Right now it's over like 21,000 subscribers and has been watched like 48,000 hours and 800,000 views. So you can check out. I try to post like video weekly, and right now it has over 400 videos and total length of more than 5 days. So if you're interested in learning more, you're welcome to check out. And here's show you some of the tutorials. For the GMap right now, I have developed 132 tutorials. So for each one, you have a full-length video that's 10-15 minutes and a short animation 20-30 seconds. But also a Jupyter Notebook that allow you to reproduce. So you can easily modify the code. You can change it to suit your needs. I don't have a full list in here. You can check out the link to see all the tutorials. And since I've developed so many tutorials, I was contacted by the Locate Press, the open source publisher, to write a book on Google Sensing and Python and GMap. So I just finished the draft. Hopefully it will be published later this summer or in the next couple months. But the link at the source code is open source, so you can check out the link here to look at the book. Basically covers all the essential features of GMap and how to use data in the cloud, how to visualize that, how to analyze that. And you can just click the link and then you will be able to actually run code from the beginning to the end. So everything is reproducible. So you can just adapt the code to your needs, and then you can do a lot of like interesting remote sensing analysis at the global scale or national scale. And you can see, for example, on the graph on the at the top here shows you some of the publications using Google Sensing. So you can clearly see there's a exponential increase in terms of the journal publications utilizing this cloud Google Sensing cloud computing platform. Okay, so next I'm going to show you some of the key features. For those of you who have never used cloud computing or might be wondering like how it actually works, and I'm just going to show you some demos. I quickly go through, and if you see anything useful, you're always welcome to come back to look at the video and the notebook. So the first one is converting Google Sensing JavaScript to Python. For those of you who have used Google Sensing JavaScript, if you're thinking about like doing something in Python, then GMap can help you save a lot of time. So you can basically copy any JavaScript examples from the Google Sensing code editor, the example documentation, then just copy, paste, then you will convert it to Python. Then you just run the code, you're able to visualize the result easily. So you don't have to manually do the conversion. Also, you can search the data set. So this one is just like the searching a movie on Netflix, right? So you want any data set, you just type the keyword and then you just search. It will show you the list of all the data sets. Then you just one click, import the data set. It will be imported to the map. Then you can visualize. You can overlay different data sets. So think about this one is that you have access to tons of geospatial data without having a desktop software to process that. So you can easily access to the right now over 80 petabyte, right? So vector data, raster data, landscape, you name it. So you have access to the entire data catalog, and this is really powerful. You don't have to download anything. You can visualize data in the cloud just within a couple keywords. Also keep in mind, this is not just for visualization. So you have access to data, but you can also do computation. Okay, so this is very different from traditional desktop computing that if you have to download the data for, you have to go to the data portal to download, and then you have to process, you have to remove cloud, you have to do composition, you have to do atmospheric correction, something like that. Now you don't have to do that because all the heavy lifting have been done in the cloud. So you can focus more on addressing the scientific questions rather than spending 70% or 80% of the time to manage those huge data sets. Besides like searching the data, if you need to inspect the data, you can do that as well. So just one click, you can get the pixel values, you can get the attributes of the data. This is just like in the desktop GIS, you click, you can get your pixel value, you can get the attribute table of the vector data, very much similar, but this is open, makes it a lot more flexible because you don't have to have the data. So Gmail basically be under the hood, get your coordinates of your mouse location, and then send the command to the cloud computing server, and then do the computation, and then run the result, and then back to the browser. And you can also do plotting. So if you want some like spectral signature, for example, if you want to look at what the data look like, landscape data, multispectral data, or hyperspectral data, it's very easy. Again, it's just one click. Under the hood, this might be 100 lines of code because the Python API, the Google Engine Python API does not have the visualization. So you have to actually write code to connect all the components together so the user don't have to do the coding by themselves. And you can visualize pretty much any vector data, raster data in the data catalog. So it can be a single, for example, elevation data set. You can change the symbology, you can change the color, you can change it, whatever it looks like. Also, you can change, for example, the band combination. So as I showed you earlier at the web app, right, you can create first color composite, you can create natural color composite. Most of the available satellite time lapse, I mean, like the global scale, if you find it on the internet, it's usually just RGB. So there's no like forced color composite or other combination because it's just a lot of data storage and it might take some time to generate. But for cloud computing in here, it's very flexible. So you can do that pretty much within seconds, and you don't have to download the data. So that's kind of the advantage. You can, for example, also visualize global land cover. So most of, especially in the past 2 to 3 years, there are more and more global land cover data set available for the entire globe, and annual land cover data, very fine scale using machine learning and deep learning. So you can easily have access to this data. You can take a look at how the environment has changed during the past decade. And you can compare the data side by side. And this is only a couple lines code. Again, if you're trying to download the data, it's going to take some time. Besides that, I also add some data integration into ArcGIS. So if you are ArcGIS user, this might be of interest to you because ArcGIS mostly for desktop computing. But if you can have access to the 80 petabyte of data from Google Engine, then that's a lot more powerful. So you can basically overlay your data on your desktop, your local data. So you can have data in the cloud, you can have data locally, and then you can do all kind of computation. Of course, the data in stored locally, you cannot use the cloud computing power unless you upload the data to the cloud. But at least you can pull the data all together. You can run the analysis using the cloud data. You can pull the result back to ArcGIS Pro, and then you can create maps, you can export maps so that you can use that for your manuscript, for project report. So this also open a lot of opportunities. And as they reach out to me, they're also very interested in expand and more features into ArcGIS Pro. So hopefully in the future, you'll be not only utilizing the Google Earth Engine cloud computing, but now you can also use Microsoft, you can use Amazon Web Services. So ideally, it doesn't matter, the user doesn't have to worry about where the data being hosted. This can be all standardized, and then they just need to know what kind of data do I want, what kind of computation do I want to run, and then you're able to do using the same step to get the data to run the analysis. Besides using the computation visualization, if you need to export data, and then GMap also provide functionality for you to, for example, create this kind of nice looking maps with custom projections. So if you're working on some area that requires a specific projection, this might also be useful. Again, this, you don't have to download data. You basically just downloading the final product. That's it. So only a couple megabytes rather than gigabyte data, because you can just run all the computation in the cloud and then finish that and then just export a small section of the results. Besides using the data in Google Engine, you can also use data from AWS, Microsoft Printed Computer. Basically, you can use data from all the major cloud computing data providers. You can, as long as they're using some standard, for example, cloud optimized GeoTIFF. So GMap basically allows you to just simply draw an area of interest, and then you can just select where do you want the data to come from. If the data is available, then you can just select and then you can search. Then you can start querying the data, more like data visualization. But I would like to point out that this is kind of different from the other data portal. You can also search, you can visualize. But the problem is that you cannot actually integrate with your data only locally or data in the cloud. So, but this one allows you to pull data from multiple locations, and you can do analysis. You can visualize all in the same platform on the same map, rather than like you have to align them together and you download the data, export the data. So it saves a lot of time and just a browser. Besides accessing the satellite data, remote sensing data, vector data, you can also access a lot of base maps. There are hundreds of base maps available, so you can just one click. Once you create a map, you just click one button, you will be able to switch lot of base maps just with one click. So in that way, you can, if you want to access some base map or schematic maps, this also makes it really easy to do. And if you are interested in seeing, for example, the changes, besides the time lapse, like I showed you earlier, there you can create an animation, a GIF animation. You can actually also create, this is called time slider. So you can visualize the satellite data in native resolution. So you can zoom in, you can zoom out, you can see how the image, how the area is changing using the native resolution rather than a static animation. So this also, if you're interested in looking things at very fine scale, this also be useful. And just couple lines code, you can create this kind of a visualization easily. If you have some local data, vector data, you can also just open the data. So without coding, so you have some vector data, shapefile, GeoJSON, whatever vector data supported by GeoPandas, you can just open it and then you can just visualize that without coding. So there's the interface in GMap that allows you to open vector data, raster data, CSV, or any like GPS data. As long as you standardize, have some columns, then you can quickly visualize data on the map. So this is data in the store locally, but you can, in the meantime, you can access data from Google Engine in the cloud or Printed Computer or AWS. Then you can pull all the data together on the same map user interface. You can create link maps if you are interested in visualizing the data side by side, different maps. This allows you to do that. So all the maps are linked together. So if you zoom in on one, it's going to change on all the maps, right? So this is, for example, NLCD link cover, right? For different time periods, you can create as many rows and as many columns as you want. Again, just a couple lines of code, then you can do something like this easily. Besides cloud computing, so I also developed some so-called front ends based on the white box tools. White box tools was geospatial data analysis platform developed by Dr. Zhong Lingji in Canada. But it's a command line program, so I built on top of the command line to provide interface with Python, with R, with ArcGIS Pro, and also with Jupyter. So that allows you essentially to run a lot of geospatial analysis in the cloud. So it's very small and compact. You don't need in ArcGIS or you don't need other desktop GIS, and you can run things using just a browser. And this makes it really powerful. So it's just like a ArcGIS toolbox, but it's open source and it has over 500 tools. And you can run LiDAR analysis, hydrological analysis, remote sensing. So there are a lot of tools that you won't find it anywhere else in ArcGIS Pro. So you can try it out if you're interested in doing some analysis using open source. This is more like an alternative. So the compute backend is using the white box, and then the visualization is using GMap. So you can visualize data before you input into the toolbox. You can also visualize data that you output from the toolbox. So you can see here, you can quickly search, you can create all kinds of data very, very easily. And this is very flexible, powerful. And again, you just need a browser. You don't need to have a powerful computer to do that, and things all run in the cloud. And so next couple examples are more like for visualization. So you can, for example, this is global wind velocity, right? If you have some next CDF data, you want to create some animation, you can do it like this, one line of code. So it's not like very complicated. And the next one here, this one is actually in the leaf map package. So it's another package that I created, allows you to do like 3D mapping. So this is pretty new. I just added maybe 2 weeks ago. They allow users to create 3D maps based on JavaScript libraries. So you can actually bring in all kinds of JavaScript libraries and then display and interact within a Jupyter environment, within a code block, and then you can do bidirectional communication. So whatever you interact with the map, you can pass some data out, you can do further computation. So this is also something very interesting that I probably will have more features coming out just to allow users to display, for example, geospatial data on 3D. And again, it's in the cloud that you don't really have to have a powerful computer to deal with it. And this is very good for demonstration or for teaching. And this might be the last one. So if you have some vector data, you want to, for example, visualize that, you want to see the evolution. So this one shows you, for example, the building evolution in Boulder, Colorado during the past couple of decades. So you want to quickly see how the city is evolving. You can also use GMap to do that. So this is just one line of code. You just passing the data, the file pass to your data, and then you specify which column contains the date. Then GMap or leaf map can create this kind of animation very easy for you. Okay, so these are some of the key features I want to share with you about GMap, and there are a lot more. So as I mentioned earlier, there's 132 features. I probably only show you 15, 1/10. You're welcome to try out the tutorial to see some of the features that might be useful to you. And next, I want to quickly mention some other project, open source project that I have been working on. So GMap is just one of those. Leaf map. I also have some other apps or a couple more Python packages. You're welcome to check out my GitHub repo. So, and on the right here, show you some of the posts shared by a LinkedIn user a couple months ago. So just show you some of the Python package for doing geospatial. The user, basically the usage increased from 20 in 2022. So you can see the GMap, leaf map, the top 4. So 3 of my packages was like within the top 4. So basically a lot of users are interested in using the package, and I'm really happy to see it's being used in the community. And I also have a repo, it's called Awesome Earth Engine, compile a list of resources about Google Engine, presentation, tutorials, resources, and even journal publications. So if you are interested in learning more about Google Sensing, you are welcome to check out the link and to learn more. Lastly, there are a couple more videos tutorials. So this is the one I did in 2021, 2 years ago in a GeoPython conference. So this one also introduced some of the key features about Google Sensing and GMap, 90 minutes workshop. And last week, 2 weeks ago, I attended the American View conference in Louisiana. I also presented a workshop for GMap and Google Sensing. So this one is 2 hours. You are welcome to try it, check it out. And this one showcase all the some of the key features of GMap and how we can use that for doing geospatial analysis and also visualization. And this might be the most updated one that I have done. You can try it out if you want. So show you all the practical examples, how you can get started from zero to be able to analyze the data, to visualize the data. Even if you never used cloud computing, you should, as long as you have the account, you should be able to follow. Basically, just clicking the button and then run the analysis, make some modification. You'll be able to run analysis at the global scale without having to download any data to your computer. And this is another one that kind of a YouTube live streaming that I did a couple months ago about a comparison between Google Sensing, Microsoft Planetary Computer, and QGIS. So just using the example how to extract flood extent in Pakistan that occurred in 2022, showing using different tools, how to start from the very beginning, how to get the data, how to analyze the data, how to visualize the data. And so just a simple comparison between different tools. If you're interested in seeing, for example, what would you do, what kind of things you need to do if you're using different platforms. This might be of interest to you. And also I have been teaching some of the courses here at the university about Google Sensing and also programming. So I also post the videos online. You're going to check out the YouTube channel. So this one is about data management with Google Sensing. I also teach another one called software design, teaching students how to build open source software. So if you're interested in building some packages, you want something to be widely used by the community, this might be of interest to you. I teach some of the practical tools or the best practices about software development for geospatial. So you're welcome to check it out. And thank you very much. That's what I have. And I look forward to your questions.
Great. Thank you so much, Dr. Wu. If everyone could just join me in sending a virtual round of applause for Dr. Wu. It's very incredible to hear about your work. Definitely a lot of new tools for me to wrap my head around. And it seems like something very exciting to work on in terms of, research, especially as we're seeing growing changes in our cities. Cities that were once rural are now growing with development. So using tools like that could be interesting to look at the impact of development on cities like Charlotte, like Knoxville as well. So thank you. So I do have some questions, but I just want to jump into the chat already to share a question here. I see from Trevor Lee, who has a question regarding if you run into any limitations using open source software, and if finding data for your software is easy, as it is for software like ArcGIS.
Yeah, that's a good question. So definitely there will be limitation of running into a limitation using open source. So as I introduced in the presentation, so you can use some free cloud computing resources, for example, Google Sensing, Microsoft Planetary Computer, or even AWS. They all provide some kind of free cloud computing. But if you are doing something very excessive, you are dealing with a lot of data, most likely you're going to run into some memory issues or data storage issues. But there's some workarounds you can deal with that. But certainly, if you're doing large scale stuff, you might eventually have to pay either the cloud storage or computing stuff. And the other limitation is that open source is a little more like very distributed. There's not like centralized software that everyone's using, just like ArcGIS or QGIS. They're basically anyone can come out with a software or package they build on top of other people's work. So if you're beginners, you have to figure out what to learn because there's so many options. It's just not like I just learn this one or ArcGIS or QGIS. It's not that true, not that easy because every package has its unique functionality. So you have to know what that package can provide. And they also have different learning difficulty levels. Some are a little bit challenging for beginners, some are user friendly, but yeah, that one is like not a one-stop shop. You can do everything. So you have to spend some time to sort it out. But there are certainly some packages that widely used, for example, GeoPandas, Raster.io, or Google Sensing, or there are a couple like very popular, but certainly there are a lot more options out there compared to just one or two desktop software. And the other one is that say finding data for this software is as easy as it is for like ArcGIS. Yes, so it's even easier than ArcGIS. ArcGIS, you can probably find some data, I can pull the data, I can run some computation, but certainly you cannot. They say right now, if you're doing on a global scale analysis, you're trying to pull all the Landsat data. They say for 2022. You are not going to be able to do that in ArcGIS, but you can do just within 3 lines of code in GMap and Google Sensing, and you can pull the data. You can do the simple mosaicing, and then you can do a simple filter. You'll be able to create a cloud-free imagery, just a couple lines of code. So certainly there are a lot more advantages in those cloud computing. But I have to point out, it has a lot of data in the cloud, but if you're trying to get data from the outside the cloud, then it's going to be painful because there are a lot of using a data streaming. So it's better to do things in the cloud, run the analysis in the cloud, and then get a summary of the result out, rather than if you're trying to get the raw data, it's still terabyte data. It's not going to work very well. Just imagine you can watch high definition movie, 1080p or 4K movie on Netflix, but if you're asking Netflix, say, I want to download this movie to my computer in 1 second, it's probably not going to do that. Okay, so it's a free resources. It takes a bandwidth, so not everyone can like get data out very quickly. But if you're getting just a thumbnail, for example, I just want a screenshot of the data. Perfect. That's only a couple of seconds. But yeah, those are some of the limitations of the cloud that everyone need to be aware that cloud can help us reduce some of the workload, but cloud cannot solve everything. So sometimes you will still have to use desktop software.
Great. Thank you very much for that. We do have another very interesting question by Ryan Brunkel, who asks, are there any opportunities to utilize this style of analysis to be predictive of future developments when assessing something like coastal erosion or deforestation?
Yes, certainly can. So for GMap, it's just basically a platform tool for you to do that. But I did not provide any specific like scientific question or findings or anything. It's more like platform that you can use. But if you want to do predictive study, you just need to develop a model based on the data, and then you can run things, the computation in the cloud. So you can have some interface. You can imagine that you have the data over there, you build on top of data, you do some training, whatever, you have a model, and then you can have an interactive web app that allows users to select the area of interest, and then you can select when they want to predict that. And so that is possible. If you already have some of those like done using traditional desktop, now this might be a good opportunity for you to think about how you transform your solution from a localized area, a limited time span, to something like at a global scale. And as long as the data supported, you can predict whatever time range you want to predict. So yeah, it's all up to the imagination of the users. If you have the solution, then you can try to how to make it scalable and then make it widely available to a large audience.
Okay. And a similar question that I had, Kelly Kallenbach also asked, are all of the tools that you shared in your presentation open to the public?
Yes, it's all open. So slides are open, source code is open, notebook is open, video is open, the book is open, everything is open. So I don't care about, it's not like any secret stuff in there. I welcome contribution. I put my stuff out there, and actually a lot of users ask questions, they find some bugs, and it helps me improve that. So it's all open source. And so GMap right now has a lot of users in the Google Engine community, and so the Google Engine team is thinking about adopting GMap into the official documentation. So we're still trying to figure out how to do that, but yeah, certainly you will see getting more examples into the official documentation in the future.
And a follow-up question from Kelly is also, is there or could there be a package for archaeology sites to visualize where artifacts were found?
Yes, certainly. So you can just look at the app, to the link they are provided. They want just give you access to some of the potential applications, but it's at the global scale. You can access to all kinds of data, basically all the satellite data image collection within Google Engine, but you can limit it, can refine it, or you can customize to just for a specific site or specific area and customize to a specific data set. So it's all possible. You just need to think about what do I want my user to be able to do and what option I want to provide. So Google Engine or other cloud computing platform, basically it's all there. You just need to narrow down and then to get something out of that so that you can present to the audience or the users what you want them to do. And then behind the scene, you can use the cloud computing to do all the computation, and use it pretty quick, only a couple of seconds. So then you can run the analysis in near real time on the fly, and then just render the results on the map so the user can quickly see what the output look like. So we can detect some, for example, landmines or some archaeological sites or something like that. It's definitely doable. Yeah.
Okay. And well, we still have about 10 minutes for Q&A session. So I'll give some of our guests some time to think about additional questions to include in the chat. But until then, I wanted to jump in with a question of my own. I see that you do have experience with the U.S. Department of Defense, NASA, and USDA for sharing your work and working on projects. But do you foresee any opportunities, or have you seen examples of where local governments, like local municipalities, using these kind of technologies to further policies or goals in different cities as well?
Yeah, it's not like directly, but certainly there will be a lot. Anyone can use. So just think about this kind of cloud computing tool. If you're trying to analyze some of the changes on the landscape, whatever policy or environmental or anything related to the environment, this will be a powerful tool that you can at least let your people know that you can see the changes, why we have this policy, how it's going to impact. For example, they say some of the animation I showed you earlier, you can see the river dynamics animation. So you can see how it's in the past couple of decades, how it impact the local community in terms of the flooding and other stuff, and how do we better design the cities, or how to better locate the cities, like to avoid the flooding, right? Those are certain things you can use to demonstrate, but it's not directly used like to inform the policy. It's all up to everyone what they want to get and what they want to showcase. The tool only help you get the data out or the visualization easy, but it's up to your imagination what you want to do. And then if you already have a solution, you just need to think about, okay, what data do I need to provide, and what kind of analysis do I want to run, and how do I want to visualize the output, and how do I want to make the data or the products available to the public, right? So for me, for example, personally, I'm not involved in those like policy decision making. But for example, for every publication, I always make the data accessible, but it's not enough. You can provide the data, store in the Google Drive and store somewhere people can download, but it's still a barrier. So, but if you can develop some app that allow users to not just download the data, but they can also use to visualize the data just using a browser, that means it much more intuitive, that user can actually see what the data looks like, and they can also run some analysis interactively. So this makes it a lot more reproducible, because as a researcher, you can always do analysis, you can do some fantastic one, but you can do a lot of manual steps that not everyone will be able to reproduce. But if you can develop something that everyone can use, everyone can reproduce, and everyone can test your methods, that means it a lot more reproducible and makes it more open. And so basically we are contributing more to open science in terms of reproducibility and how to make things more replicable to the old readers.
Okay,
Mhm.
great. Thank you. I see in the chat, we do have a question from Dr. Chen. Dr. Chen says, excellent and informative talk. My question is, what machine learning algorithms are available? How easy is it to integrate our algorithms, for example, deep learning, into the cloud environment?
Yeah, so a good question. So the machine learning right now in the Google Staging platform is limited to some of the traditional machine learning, random forest, decision trees, support vector, machine gradient boost, something like that. Deep learning is not delivered within there. So it's not as convenient because you have to export the data, basically the image chips after Google Staging, and then you need to send that to the Google AI platform to do the training. And then once you have the model, you can import the model back to Google Staging. Then you can do large scale, global scale, for example, prediction of land cover, whatever. So one of the data product that Google Staging came out was the so-called dynamic wall data set. One of the key features that I saw earlier, like you can see the land cover, different land cover. So that one they use deep learning, but it's not right now, not directly within there because deep learning usually require a lot more computing resources. So you have to GPU or something like that. And so Google Staging right now does not provide a one-stop that you can do everything within Google Staging. You have to have export data. So it's not as convenient, but it's certainly doable. And Google Staging, their documentation also have some examples. They use TensorFlow to do deep learning, but hopefully in the future it'll be easier. But I certainly understand the point because this kind of a deep learning is a money-making business because you use resources. So they want you to use the AI platform to do the computation and then do the get the model out and then do the prediction within Google Staging. But that's kind of to me is I don't see they are changing it right now. So you will have to figure out a way to how to make it scalable. But you can also use other platforms. Some others might be much easier, better integrated with deep learning, for example, Plenty Computer, because those are using open source packages. So the downside is that it doesn't have a central API like Google Staging. So you will have to figure out things on your own. Basically, you need to put the things all together. Google Staging, the advantage it has an API. They can run computation easily, just calling a function. You can quickly create a mosaic, or you can quickly detect something. Other packages, you have to maybe pick 10, 20 packages and then put all the things together. So it's not as convenient, but it's more flexible. It's more open. So this is kind of some trade-off that you have to consider. But hopefully in the future, it will become easier. That everyone can just go online and then say, oh, I want this data. I want this deep learning model. Give me the result. And then boom, you have the result. But it might take a couple more years before we can get there.
Great.
Sorry, can I ask a follow-up question?
Yeah, sure.
So I think it's very good presentation. It's got a lot of information. So you mentioned most of the cases is free, right? Like
Yes.
Google's engine. I have used that before, but I'm just curious, under what circumstances they start to charge you, by using their resources?
So it says free for resource and education. So if I just using that for resource, for study, and also for teaching and other stuff, is free. But if I start using that, develop something that is providing to the customers, and you are making profit out of that, then you will need a license. So it's in the past, it's kind of a gray area because they don't have a commercial offering. But last year they released a commercial offering. So they have terms and agreements. So now you can use it if you want to use it for commercial purposes, but you need to have a license, and then they're going to charge you based on the compute unit, how long you use, how much computing power. So it's more like similar offering to other cloud computing platforms. But I see it as a good thing for Google Staging because it's a free lunch, but all the free lunch will end someday. But if you have some commercial offering actually to support it, then it might last much longer. Otherwise, it's a bit concerning because all those big techs, they can do some free for free. But over one day, if the economy is not good, there's cutting budget, then the program might be cut just all of a sudden, and no one will be prepared. Now we are all kind of addicted to this because it just makes things so much easier. But you always have to be careful. If you cannot use this one anymore, what are the options? Luckily, right now in the open source community, there are other options available, but it's just not as convenient as this one we have. But I think overall, the trend is that we are moving towards the cloud because we're getting a lot more data set, and we need to use the cloud no matter what. And so one example would be right now, for example, for Landsat, like we have Landsat 9, and Landsat next, basically the next generation will be launched by 2030. And so the resolution will be increased to 10 meters, and the spectral bands will, I think, up to 18 or 20. So you will basically, right now the Landsat 9, one image is 1 gigabyte. In the Landsat next generation, when it comes out, it will be like 3 times of the resolution and then twice of the spectral band. So you'll be 20 gigabyte. So each image is going to 20 gigabyte. Think about in 7 years, you are just dealing with one small area, 20 gigabyte, and even doing global scale, it's just not possible. So we have to prepare ourselves for the new generation of the data. And then said it's going to be exponential growth in terms of data. So, but always keep it in mind, have on something alternative. If this one doesn't work out, is there something I can do? But at least like not totally cut off, but you can have some other alternative that just in case. But I'm sure I think new development come out. I'm not too much worried, but in the past I do a lot of Google sensing, but now I kind of mix more like AWS and also planted computer. So trying to diversify, like use more tools, and then so you did know a little bit more and then be better prepared.
Thank you.
Yeah.
Great. Well, thank you, everyone. Unfortunately, we can't get through additional questions that are in the chat because we are at time, but I want to say thank you to everyone who joined us. Thank you especially to Dr. Wu for making time out of their schedule to join us virtually at UNC Charlotte. We hope that one day we can cross paths in the future, maybe come in person one day to UNC Charlotte. But thank you for your work. It's so exciting to learn more about, and we wish you the best. So we will provide the recording to on our website page and share it with you as well.